Welcome viewers. In this video we'll see the dynamic memory allocation available in the C programming language. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic dynamic memory allocation in C programming language. The process of allocating memory at runtime is known as dynamic memory allocation. So during the runtime we are allocating the memory, that's why it is called a dynamic memory allocation. Now we'll see what are the functions available under dynamic memory allocation. The first one is malloc, M-A-L-L-O-C, malloc, that is nothing but allocates required size of bytes and return a pointer to the first byte of the allocated space. So memory allot, this malloc is called memory allot. So it will allot the required size of bytes. Then it will go to the pointer. So while using the dynamic memory allocation, we need to declare pointers. The pointer will go to the first byte so that we can store the data in the first byte. Thereby second and third byte so that the pointer return to the first byte. Then calloc, allocate space for array of elements. This is malloc. We don't know the size, but here is given the for array of elements. What is array? Array is the set of same type of data. Integer a means integer type. We can store one data. Integer a of 10 means a single dimensional array. With the name of a, we can store 10 different integer data. That is a of 0, a of 1, a of 2, like that. We can store 10 data. So the array, for allocating the memory for array, we are using calloc. Initialize them to 0 and return a pointer to the memory 0 because array starts with 0. A of 0 is the first element, right? Then go for the remaining. What are the remaining memory allocation, dynamic memory allocation functions are available? Free, previously allocated space. So here by using malloc, calloc, we allocated the memory. By using the function free, it will free the allocated memories. Realloc, so already allocated, it will modify the size of the previously allocated space. By using malloc, calloc, we allocated. If any modification is there, we can use realloc. Then malloc, this example how to use the malloc. Pointer, cast type, malloc, byte size. Cast type means the example available here, x equal to, this pointer is x. Integer, we are going to use integer, malloc, 100 into size of integer. So what will happen? So it is the integer type. How many data we need? 100. So 100 into size of integer. For an integer, some size is available. 100 times it will allocate the memory, that is indicated by the pointer x, right? So here we are allotting 100 memory space for storing the integer data type, right? For example, the size of integer may require 2 or 4 bytes. So 4 bytes into 100 space will be allocated. Then calloc, how to allocate the calloc? Pointer, cast type, calloc, n, element size, right? Element size. For example, it is a integer or floating point. What is the size of the integer? How many array elements are you are using? 100 or 10. That is indicated by n, right? Then free is very simple. Free pointer. So this pointer is already allocated. Free pointer means the already allocated memory will be free. Already allocated memory will be freed. It will free the memory space. Realloc, pointer, new size. So already allotted size is there. If you give the new size will be allotted in the same pointer, right? So we have malloc, calloc, free, realloc, 4 pointer, 4 dynamic memory functions available. We discussed this. Now we'll see one example program for further understanding. So the program to calculate sum of n numbers entered by the user using dynamic memory allocation. the program, simple program, sum of n numbers using the dynamic memory allocation. First we'll start the main program, void main, open the brace, integer n. N is the n number, how many number we are going to use. We need a for loop, so we are declaring I. This pointer, we already discussed, while using the dynamic memory allocation, we need pointer type data, star PTR, so integer type. Sum equal to 0. We are going to add n number of n numbers into, we are going to add, first initially we'll keep sum equal to 0, thereby we'll add the numbers one by one in this variable sum. So this is number of elements used for loop. In order to use the dynamic memory allocation, we use star PTR. The final answer we are going to in sum, that is we declare 0. First we'll ask the user to enter the number of elements. Printf enter number of elements. Scanf %d and n. Right, address of n. %d refers integer type. Then and n address of n. The number entered by the user will be stored in n. Now we'll go for the memory allocation. How to allocate the memory. Pointer, we already declared pointer. We know that is a integer star malloc, size of integer. How many integers are needed? That is given by n. If n equal to 5 means 5 into 10 means 10 into. So that number of size of integer is allocated. This malloc is used for allocating the memory. Right. If memory cannot allocated, we need to check. If pointer equal to null, that means suppose the n is very large or some other error is there, the memory is not allocated. So that is verified here. If pointer equal to null, double equal to mean it will check. Printf error, memory not allocated, exit. The program will be completely exited. Right? Due to some error or large number of memory, sometime memory will not be allocated. That is, we can check the pointer. If it is null, mean memory is not allocated. Otherwise, we can continue the program. Right. Now the memory is allotted. We check the memory also. It is not a null. If it is null, it will exit the program. Now we ask the user to enter the elements. What are the elements to be added? So n number of elements available. So we are open the for loop. For I equal to 0, I less than n plus I. Scanf %d pointer plus I, because the elements are stored in pointer. Right. So initially I equal to 0. Pointer plus 0. That refers first element. Right. Sum equal to sum plus star PTR plus I. The first element entered is added with the sum stored in sum itself. Sum is already 0. So what are the element we entered, that will be added. 0, for example, 10 means 0 plus 10. 10 will be stored in sum. Now sum become 10. Earlier 0, now 10. Then it repeated. For example, 10 numbers means it will last 10 times. So all the numbers what we are entered is added with the sum, cumulatively added. This I is incremented because of increment operator. Initially pointer plus 0, first number. Pointer plus 1, second number. Pointer plus 2, third number. Like that it will execute. So after executing this for loop, all the sums, all the numbers are added. That can be printed. Printf sum equal to %d sum. The added values is printed. Then we can deallocate. We already allocated the memory. Deallocating the memory. Free pointer. So already allotted memory will be freed. It will be free the memory space. Then close the program. So in this video we discussed dynamic memory allocation. Allocating the memory during the running time. There are 4 functions available. We discussed the 4 functions. Then we discussed one example program. Sum of n numbers using dynamic memory allocation. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.